All right, hey guys. Tonight's notes we're going to be talking about constant rate of change. So let's talk about what that is. A rate of change, you can highlight that if you want, is a rate that describes how many quantity changes in relation to another. In some relationships, the rate of change between any two quantities is the same. These relationships have a constant rate of change, okay? So the best way to explain this is to look at an example. So let's look at this first one right here. Number 1 says the table shows the amount of money a booster club makes washing cars for a fundraiser. Use the information to find the constant rate of change in dollars per car. So that means for my word ratio, I have dollars per car. Remember we talked about writing that the other day, that we write it in order. So since it's dollars per car, it's dollars over cars. Okay, so let's look at what's changing. First, let's look at the number of cars. I see that it goes from 5 to 10 to 15 to 20. So it's increasing by 5 each time. Okay? Now let's look at the money, the dollars. It goes from 40 to 80, so it's increasing by 40. 80 to 120, it's increasing by 40 again. And 120 to 160 plus 40 again. So we're going to find the unit rate to determine the constant rate of change. When we're given a table like this, we're just going to look at the change. First, we're going to look at the change in dollars. And I'm just going to put a dollar sign. So the change in money over the change in cars. Well, I just told you the change in money, we see it's going up 5. That's not the money, that's the numbers. The money is going up 40 each time, okay? I did my color coding wrong. So, the money is 40, the cars are 5. So the money goes up 40 each time, and the cars goes up 5 each time. So to find the unit rate, remember we just do top in, bottom out, and we get $8 per car. And since it's constantly going up by 40 and constantly going up by 5, this does have a constant rate of change. All right, let's look at these two problems over here. I want you to try these on your own. Go ahead and pause and try to do it right now. All right, you should have paused and tried to do these problems. So this first one says the table shows the number of miles a plane traveled while in flight. Use the information to determine the approximate, notice that word approximate, that's important, constant rate of change in miles per minute. Okay, so all I did is look at the change in time. I see it's going up 30 each time, okay? And then I look at the change in distance, it's going up 290. And since it says miles per minute, I did miles over minutes, 290 over 30. I got 9 2/3, but that word approximate means I can round. So it's 10 miles per minute, approximately, okay? B says the table shows the number of students that buses can transport, not support. Use the table to determine the constant rate of change in students per school bus. So I did students per bus, and then I looked at the rate of change. It's going up 1 for each bus, and for the students, it's going up 72 each time. So I did 72 over 1, so it's 72 students per bus. Okay, now let's look at number 2. It says the graph represents the distance traveled while driving on a highway. Determine the constant rate of change. So we're looking at miles per hour. Okay, so to determine the rate of change, we're going to pick any 2 points on the line, such as 0, 0, and 160. So I'm going to circle those. I'm using these 2 points. Now, looking at those two, I'm looking at the change in miles over the change in hours. So if I'm looking at the miles, the distance is on the y-axis. So from 0, 0 to 160, the change in miles is 60. I see that right here, okay? So I'm going to put 60. And then I see the x-axis represents my miles. The change in x is just 1 whole. So that means my rate of change is 60 miles per hour. Okay? Number 3 says explain what the point 0, 0, and 160 represent. So it already describes it for you. It says the point 0, 0 representing traveling 0 miles, which would be our y, 0, right? Put an x, but it's y. 0 miles in 0 hours, which is our x. The point 160 represents traveling 60 miles in 1 hour. Notice that this is the constant rate of change. It's also our unit rate. When we're trying to find what it is for 1 hour, that's what our unit rate is. Okay, so now I want you to pause and try to do C and D. All right, you should have paused and worked C. You should have worked C. So here's what I got. When I used the graph, I was you're determining the constant rate of change in miles per hour while driving in the city. So the miles, I saw the change in it was 30, and then the hours were 1. It went 1 whole hour. I see that right here. Okay, so it was 30 miles per hour. And then down here, you should have written a description similar to that in number 3. Okay? All right, looking at number 4, it says the table and graph below show the hourly charge to rent a bicycle at 2 different stores. Which store charges more per bicycle? Okay, so looking at Pedals Rentals right here, I see that it's increasing in cost by $12 per hour, and the hours are just going up by 1. So I'm going to look at cost over hours, and I have 12 over 1. It's increasing by 12 each hour. So $12, it says that right here. Okay, so now let's look at supercycles. For 1 hour, that's this line right here, it's $8. Do you see that? So the cost over hours is $8 for 1 hour. So it says Pedal Rentals charges more per hour, which is true. It costs $12, where Supercycles is $8. So the better buy, like what we talked about today, is for us to rent from Supercycles. It's only $8. Okay, flip over your paper. It looks like this, where you have like 2 sheets on one side. I have it blown up a little bit bigger so you can see it better, but it's the same paper. Okay, so it's the same definitions up here. We have rate of change, which we talked about on the other side, and then proportional relationships is just a relationship between 2 quantities in which the ratio of one quantity to the other quantity is constant. And then a proportion is an equation that states that 2 ratios are equivalent, which just means that they're equal. Okay? And then constant of proportionality K is a constant ratio of 2 variable related proportionally. Wow, I can't read today. Proportionally. So this is how we find our K. K is the constant proportionality. We're going to talk a little bit more about this later in the week, but for right now, you need to know that constant rate of change, what we were doing. We were finding the change in, one of the examples was change in miles over hours. So that's just this. Y would have been miles. X is hours, which we saw on the graph that the Y was the miles, the X was the hours. It's just another way to write that. And then the equation would be Y equals KX. So if you needed to write it in an equation form, you could write it like this. Okay, let's look at this example. In 1 hour of babysitting, Rajiv makes $8. He makes $16 in 2 hours. Oh, the light's not on. That's why it looks dark. Sorry. Ooh, it looks better with it off. Okay, he makes $16 in 2 hours and $24 in 3 hours. The same information is shown in the table, which we see. Time worked, he worked 1 hour, made $8. He worked 2 hours, he made $16. He worked 3 hours, he made $24. So to see if this relationship is proportional, we're going to find out if the rate of change is constant. So we're going to express each rate of change shown in the table as a fraction. So all we're doing is doing this Y over X, like what we were talking about. So in this example, our X is the time worked, and our Y is the wages. So we just did Y over X. So 8 over 1, and we got 8. You do the same thing here, y over x, so it's 16 divided by 2, which is 8. Same thing here, y over x, 24 divided by 3 is 8. So we see that the rate of change for each column is the same. Because it is constant, the relationship is proportional, okay? You can express a proportional relationship by using the equation y equals kx, where k represents the constant rate of change between x and y. So once you find your k, so in our example here, k is 8. You can just rewrite it as an equation as y equals 8x. This equation represents the information from this problem up here. All right, let's flip it over. It says a giant tortoise moves at a slow but steady pace. It takes the giant tortoise 3 seconds to travel 10.5 inches. So the first thing I want to do is complete the table. So let's first find the unit rate so we can find what 1 is. Remember, to find the unit rate, you just write your word ratio and then divide. So mine is going to be distance in inches over seconds. And I was given 10.5 inches in 3 seconds. So now I'm just going to divide. 10.5 divided by 3. 3 goes into 10 3 times. I see 3 goes into 15 5 times. So that means for 1 second, it took them 3.5 or went 3.5 inches. So now, this is going to be constant. So it's going up 1 here. It's going to go up 3.5 each time. So I just have to add 3.5. So go ahead and pause and add 3.5 to each of these. So I got 7, 14, and 17.5. So now for each column of the table, we're going to find the distance and the time and write each fraction as a decimal. And put the distance in the numerator and the time in the denominator. So we're doing that y over x. So we're just doing each one. So 3.5 divided by 1 gives us 3.5. If you do 7 divided by 2, which is my next column here, I get 3.5. If I do 10.5 divided by 3, which is the next column, I get 3.5. We actually did that one, that division up here. Okay, then if I do 14 divided by 4, you get 3.5. That was that one. And then the last one, 17.5 divided by 5, you get 3.5. So now to write the equation for this relationship. My k for this question was this 3.5. This is my k. So when I want to write my equation, I'm going to use the form y equals kx. So it's just y equals 3.5x. Okay? We're going to leave these last two tables blank. The example 1 down here, we're not going to worry about those right now. Make sure that you have your notes completed before class tomorrow, and we'll be talking about this more in class. All right, have a good night.